So morning guys, here we are on example 7 and I'm just going to go through this in the usual way for your notes. As usual, take notes etc. as we go through this. So let's start by reading the question and see what the key things are. If you want a title for this, by the way, it's static rigid bodies. So a uniform rod, so it's uniform. Mass 40 kilograms. So the fact that it's uniform is going to tell us what? Yep, that the mass acts at its centre. The length, 10 metres. Rest of that on a rough horizontal ground, and that's A. The rod rests against a smooth peg, C, where AC is 8 metres. It's in limiting equilibrium at 15 degrees to the horizontal. Excuse me. So try and represent that information on a diagram. Okay, have a go, pause this, and then start again in a moment when you've had a go. Okay, here we go then. So we've got a rod of length 10 metres resting on rough horizontal ground at the point A. So that is 15 degrees. 15 degrees. We know it's a uniform rod, so its weight is going to act at its centre. Its mass is 40 kilograms, so we've got 40 G acting downwards there. We know that the total length is 10. So that to there is 5 metres, and then we've got a pivot or a peg, a smooth peg at C, so that's C, and we've got then, that was AC was 8, so that is a further 3 metres. Now, what other forces are going to be acting on there? Well, as this is rough ground, what's acting at A? We must have a friction, which is opposing the attempted motion. So this rod would be trying to slide down. So the friction is acting to the right in the orientation I've drawn it. We've also got a reaction at A. Okay. Now the peg is smooth at C, and the reaction at C, you may have made a slight error here on your diagrams, but you've got to understand that the reaction is going to be perpendicular to the rod. So we've got RC perpendicular to the rod. It's not vertical or horizontal. Yeah, the actual reaction is perpendicular to the rod. Okay, so now we can try and answer the question. Find the magnitude of the reaction at C. So we've been asked to find the value of RC. Now our first instincts might be to resolve horizontally and resolve vertically, and there would be nothing wrong with that, and I suspect we'll have to do that for part B anyway. So if you chose to do that first, it wouldn't be wrong. But when I look at this, I can see that if I take moments about A, I can eliminate the forces RA and the friction, which will only leave me with one unknown, RC. And if I've got an equation with one unknown in it, then I know that I can solve it. So I am going to take moments about A. The anti-clockwise must equal the clockwise since it's in equilibrium. And then for the anti-clockwise moment, we've got RC, and the perpendicular distance to its line of action is that 8 metres. because we've said RC is at a right angle. So we get RC times 8, and that's going to be equal to the 40G, and its perpendicular distance to its line of action is along here, which we know is 5, and it's next to the 15, so it's cos of 15 degrees. So we are going to have 40G times 5 cos of 15. So RC straight away, divide down by the 8, so 40 over 8 is 5, 5 times 5 is 25G cos of 15. So cos of 15 is pretty big, so we're going to be somewhere over 200 probably. Let's tap that in the calculator, and RC is going to come out to be 237 newtons to the nearest whole number. We might argue that it should be to two significant figures because we've used G as 9.8, in which case you'd have 240. Okay, that was part A. Now let's think about part B, the coefficient of friction between the rod and the ground. So the coefficient of friction between the rod and the ground. So what equation do we know to do with friction? Well, let's have a look. It's in limiting equilibrium if we go back to the question. Yeah, so limiting equilibrium we're told here. Yeah, limiting equilibrium. So we know then on point of slipping, friction is equal to mu R. So that tells us we need to find an expression for friction and an expression for R. Well, we revert to our usual standard things. Let's resolve parallel and perpendicular to the plane. So we're going to resolve parallel to the plane first of all, taking the right as positive. And if we look at that, we've got the friction. Now, RA and 40G have no horizontal components. What we do have up here, though, is RC. So RC is made up of two bits. We've got a vertical component. So that's going to be RC, and if we take that angle, RC cos of something. Question is, what is that something? So we've got 15 degrees here, so this has got to be 75. This we've already said is perpendicular, so that's 90. So that must be 15 degrees. So the blue bit here, RC, it's next to the 15, so it's cos of 15. We've also got a horizontal bit. Notice the way the two forces, the blue and the red, add together to give the black. So we get, and this again here is a right angle. So this is, the red is opposite the 15, so we're going to get RC as the hypotenuse, opposite the 15, so it's sine of 15 degrees. So when we're working horizontally, we've got friction minus RC sine of 15 is equal to 0 since it's in equilibrium. So friction is equal to RC, which we know is 237. Yeah, from here, 237. So that's giving us the 237 in for RC. Sine of 15. Sine of 15 degrees. Okay, so the normal reaction R we're going to have to resolve vertically. And I think we've done most of the work for this already. So if we look vertically, what have we got on here? So if we look at the vertical bits, we've got RA, we've got the 40G, and the RC cos of 15. So, RA, anything else up? Yes, RC cos 15 plus RC cos of 15 minus 40G is equal to 0. So RA equals 40G minus RC cos of 15. Again, RC we know, so 40G minus 237 cos of 15. So we've substituted in for RC here is 237, just as we did for the horizontal one. And now we can substitute those two results into friction equals mu R. So we get friction, which is 237 sine 15 is equal to 40G minus 237 cos 15, don't forget the brackets, times mu. So that's substituting into friction equals mu R. So mu then is equal to 237 sine of 15 over 40G minus 237 cos of 15. That's going to need tapping in a calculator, and we're going to get around 0.4-ish. So let's just check that. 0.37 to 2SF. Hope that helps, and I'll be doing example 8 shortly.